Okay, this video is about system classification. In this particular case, we're looking at bounded input, bounded output stability. All right, so the first thing I'm going to do here is talk about the definition. So we're talking about the system, all right, the system that acts on the signal X. So X is the input, Y is the output, T is the system that transforms the input to an output. All right, so it turns out that almost a necessary property for most useful systems. There are exceptions, but this property is that the system needs to be bounded input, bounded output stable. All right, so what does that mean? Well, what that means is if you put in a bounded input, and so this definition I've written here is what it means to have a bounded input. All right. What we're saying here is that for all n, the magnitude of x is bounded by some finite number mx. Okay? If I put that bounded input into the system, I get an output that also fits the definition of being bounded, where for all n, the absolute value of y is less than some finite number. Okay? So there you go, that's the definition. The system is BIBO if every bounded input that you put into it, with no exceptions, produces a bounded output. Okay, so to more fully understand this concept, I think the first thing you have to understand is what does it mean to have a bounded signal? All right, so some signals are easy. So for example, if I took x of n to be, say, cosine pi over 3n. All right. So that particular system is just a cosine. You know, I can try to draw the envelope of a cosine. We are getting samples of that cosine, and it's bounded when you take its absolute value. Of course, when you take the absolute value, it converts it to all positive, and so these would go away and would be looking like this. And the point is, you know, we have this sequence given by cosine pi over 3n. This is probably not an accurate graph, but you get the idea. There is some number, all right? In this particular case, the number is 1, all right? Every term in the sequence is less than 1. All right, so this is bounded. All right, so let's take a look at a signal that's not bounded. All right, so let's take x of n to be n u of n. All right, so sometimes I have students that get confused because they say, well, you give me an n, all right, so let's say n is 1 million, all right, then 1 million is a finite number. Why is this not a bounded signal? For every n that I give you, it'd have a finite number. Well, the answer to that question is you have to look at this over all time. Okay, so we have this signal. This is a ramp function, so it starts to grow. Right? You need to be able to find some threshold mx so that the signal is below, the absolute value of the signal is below mx for all n. All right, so no matter how big you make mx, if you make mx to be 1 million, at n equal 1,000,001, you're going to exceed that particular threshold. So no matter what, if you keep going with this, this ramp function, you will eventually cross the line and it will not be a bounded signal. Okay? All right, so, and remember, we take absolute value, so we're looking at what happens for the absolute value of the signal. The only reason we do that is so we don't have to worry about things going to either minus infinity or plus infinity. Okay. All right, so once we know what a bounded signal is, we can start talking about bounded input, bounded output systems. All right, so let me give you an example of one that is BIBO. Okay, let's make y of n equal 2x of n plus 5 x of n minus 3. Okay? All right, is this system BIBO? And how would we prove it? Okay, well, what we know is, suppose x is bounded. So this is a general representation of x. The only property it has is it's bounded. So there exists an mx such that absolute value of x of n is less than mx for all n. Okay, so if I plugged this signal into the system, I could look at y of n. Okay, so y of n is 2x of n plus 5x of n minus 3. And because I'm worried about is y of n bounded to determine whether this is a BIBO system, I take the absolute value, all right, and then I start using inequalities, all right. So the absolute value of a sum, this is a well-known inequality, is less than or equal to the absolute value of the individual pieces. The 5s can come out, the 5 and the 2 can come out, but it doesn't matter. Okay, so that'd be less than or equal to 2mx plus 5mx, because mx is the bound on x, which is equal to 7mx. But if mx is finite, then 7 times mx is finite. So we've proven that this system is BIBO. Okay. All right, so let's talk about a system that's not BIBO. That's an example of one that is. Let's talk about one that's not. Okay. All right, so let's make the system y of n be the sum from n equal minus infinity to infinity. Let's do k. K equal minus infinity to infinity. Getting there. K equal minus infinity to n of x of k. All right. So this is similar to an integrator that we would have in continuous time, where we're just adding up the signal for all time. All right. So what if we applied x of n as u of n, just a unit step? So the first question is, because we're trying to address the question of BIBO, we need to start with x of n being a bounded signal. So is x of n bounded if we use a unit step? Well, of course, a unit step is bounded by 1 for all n. Okay, keep in mind, what we're doing here is trying to find a counterexample. All right, so if I apply that, y of n is sum from k equal minus infinity to n of u of k, all right, then what I get, if you think about it, what I get is n, well, let me unroll that a little more. Okay, so k goes from minus infinity, so I would have u of minus infinity marching all up to minus 2, minus 1, u of 0. Okay, so if I chose an n value like y of 2, this would be the answer. Okay, dot, dot, dot back in the negative direction. But all these are 0, and here's a 1, here's a 1, here's a 1, so I would get 3 for y of 2. All right, and y of 3 would be 4, and so forth and so on, and you can deduce that y of n would be n plus 1 u of n. Okay, so x of n is bounded, and then this is an unbounded signal. We talked about a ramp function before. This is a ramp, and it's unbounded. All right, so this particular system is not BIBO. All right, so there's a short, video that starts us on the path of identifying bounded input, bounded output systems. We'll work through a lot more examples as we go through the course.